I am going to present our work, Domain-Aware Unsupervised Hyperspectral Reconstruction for Aerial Image Dehazing by Bits Pilani and IIIT Kota from India. It is often seen that haze has domino effect on arriving and departing flights at airports. These delays are troublesome for everyone. As the aerial images are perceived from a considerable distance, these images often suffer from low visibility, color shift, and blurriness due to changes in the atmospheric path. Such atmospheric effects, especially non-homogeneous clouds, fog, and haze, degrade the quality of input images. Therefore, there is a need to address visibility improvement before aerial images can be used in aerial vision-based systems. In this work, the input hazy RGB image is used to reconstruct hyperspectral images using a modified cycle-consistent framework. The proposed framework is a low-cost and efficient approach to generate hyperspectral images in an unsupervised manner. Further, we present the practical applicability of reconstructed hyperspectral images for aerial image dehazing. Hyperspectral images consist of spectral reflectance information from a large number of wave bands. The key motivation to use hyperspectral images for dehazing is to utilize the entire visual spectrum, which provides rich information content. Since the perception of an object depends on its nature to absorb different wavelengths, this work proposes to enhance the visual contrast of an image by acquiring information from different spectral regions. From the shown figure, it can be inferred that spectral reflectance has a remarkable impact on image contrast. For example, the tree-like texture on the right becomes more distinct as we go to higher wavelengths. The high cost of hyperspectral image acquisition devices and the lack of large-scale hyperspectral image datasets are some of the impediments in wide-scale acceptance of hyperspectral images in general computer vision. Acquisition of full spectral signatures using a hyperspectral camera is a costly endeavor, not only in terms of hardware, but it also hampers the viability of unmanned aerial vehicles and other radio-controlled aerial vehicles. Therefore, we reconstruct hyperspectral images from RGB images. As the problem of hallucinating a plausible spectral signature is under constraint, we reformulate the reconstruction task as a spectral reflectance interpolation problem. The hyperspectral images are reconstructed from RGB images without paired image examples using unsupervised domain adaptation. The algorithm is based on the assumption that there is a rich underlying spectral dictionary that can be used to reconstruct novel hyperspectral images. Apart from domain adaptation, the framework makes use of several guiding principles such as task supervision and adversarial distribution discrepancy alignment via backpropagation. The rich information from multiple wavebands in hyperspectral images alleviates image degradation caused by aerial haze. However, the distribution of values in a hyperspectral image varies drastically from that of RGB images. This distributional discrepancy poses as a hindrance in direct hyperspectral to RGB translation. Therefore, we train a ResNet to obtain relevant feature distribution. We refer to the obtained features as a hyperspectral catalyst as an analogy to physical chemical reactions. Thus, the proposed SkyGAN can be summarized in three components: spanning, hyperspectral reconstruction, and finally image dehazing. To conclude, the paper presents a GAN-based framework referred to as SkyGAN, which utilizes hyperspectral guidance and multi-Q color space for aerial image dehazing. In addition, we introduce a large-scale synthetic aerial haze dataset. In the following figures, we compare the qualitative performance of SkyGAN with several state-of-the-art dehazing models. Hyperspectral guidance is surely a promising approach in computer vision. It would be very interesting to see further research in this direction to enhance the existing vision-based models. Thank you so much for your time and kind attention.